Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer, sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Test code is code. You're going to hear that several times in this episode. Just like with real code, certain patterns emerge when writing automated tests for your code. The patterns or observations about the best way to write tests help us to design our automated testing to best optimize the code and our time. In this episode, we're going to talk about a few of these patterns. Some are rather similar to coding design patterns that we've discussed before, and some are specific to automated testing. But before we get started, Will, what have you been fighting this week?
Well, and this is going to be a little bit rough. Work is not going so well. I feel like the environment has changed and I've changed, and it's not like at the, absolute end state yet, but right now I do feel like it might not be where I want to go. And so I'm trying to make some decisions about what to do next. And one of those options is potentially, leaving there and doing consulting again. I kind of miss having new problems instead of beating to death the same old problems for year after year. And I think I kind of need that to grow. And the other thing too is I do a lot of other stuff. Like I do a lot of writing. I do a lot of, making content like what you're listening to right now. And I feel like there's a place for that isn't what I'm doing at the day job. And so I'm just kind of thinking through that stuff. And it's been a lot of really heavy thought trying to figure out what I want to do next. So how about you?
Well, on that, I've been deep in the world of OIDC or OpenID Connect and OAuth 2.
Yep, I've been there not that long ago. Trying to get a workflow with Identity Server and Windows Forms to work.
Oh, wow. Wow. There's actually a pretty decent Pluralsight video on, or set of videos, I guess, course.
I convinced the other senior dev to do it. That's how I got it done. It's got
some good stuff on Identity Server. It really wasn't helpful for what I was doing. We're moving to .NET Core, and I've been tasked with working out how to use a third-party SSO solution to authenticate and authorize our APIs. Honestly, it's a lot of fun researching. Kind of frustrating, though, because it's mostly set up in configs. Not a lot of coding or like real problem solving, because the problems that I've been dealing with are more like a misunderstanding this one thing, or, I didn't set this up right in the config. And it's just, it's not like, I got to figure out how to do this with these constraints. It's, you didn't put that in right, or you put the wrong address here, or it's been a pain.
Yeah.
But it's also been really cool. So it's kind of like a mixed bag there.
Yeah, I do not like configuration-based coding.
Yeah,
where everything is a config file and then you just have some little deal that reads it. Like that drives me up the wall. I
do like that a lot of things happen automatically, so I don't have to go in and set stuff up manually. So I can, once I get the config set up, it's done, and then I can go into my code and just use things. That I like. It's just this figuring out the configs, it's the pain. Y'all had a really great time down in Chattanooga with my family. Took my new camera, and over 1,000 photos later, a little overwhelmed with the editing of them. Some of them turned out wonderfully and really amazing. A lot of them turned out terrible. I'm just getting back into photography. Will probably remembers how much I was into it back in college. My dad gave me an old Minolta. It's a brand that's not even around anymore, I think. Camera he bought back before I was born. Tells you how old that camera was. He gave it to me when I was in high school, and I took it to college with me, and was really into it. Did some photography for the newspaper and a bit of editing for that too, but never really got much more into it after that because I just didn't spend the money on buying myself a new camera. And then as the 1 hour photo and wolf camera and like the development went away, I just sort of stopped doing it. And phones got to be to the point where you could take pretty decent pictures on them. But my friend Alicia at church, she is a photographer and told me to get Photoshop and Lightroom. There's a pretty decent deal. Like, I think it's $10 a month for them, so it's not that bad. And so I signed up for it. There's actually a student, because I'm a student, even though I'm not a student of photography, I can get a discount, so that's kind of cool too. But I've been learning that, so it's pretty interesting. So y'all, we are closing out our book this month in the book club. The Elements of Computing Systems closes out talking about higher level or human readable languages and systems. Chapter 9 introduces a high level language called Jack. It is a simple general purpose object oriented language. Then in chapters 10 and 11, the book focuses on building a compiler to translate the code written in Jack into machine language that the virtual hardware built in the earlier chapters can understand. And finally, in chapter 12, we complete the puzzle by working through building a basic operating system to run on the hardware. Y'all, I've given a very high-level overview of this book. And I went through it in a semester, roughly about 3 months, but it could take a bit more time than that to really delve into all the details and do everything and all the activities in there. Our next book is going to be a bit shorter and more business-focused. Even as developers, we need to understand the business world that exists around most of us. Who's talking to us this week?
We got an iTunes review from Johnny Miles saying, "Me gusta. I love this podcast. I started listening to it when I began working at a warehouse this summer. Since I was allowed to use one headphone while working, I took the opportunity to listen to this podcast to gain more information and perspective on working in the field. Thanks to this podcast, I've been getting more and more interested in CS, and it's definitely motivating me to code more and continue my degree."
Thanks, Johnny. We aim to be motivating and helpful. That's one of the purposes of this podcast. Will and I created this to be sort of that motivation, both for ourselves and for our listeners. Send us an email to waterbottle@completedeveloperpodcast.com with your contact information, because we've got a Complete Developer water bottle just for you. Guys, if you'd like your very own Complete Developer water bottle, leave us a review on iTunes or comment on the website or any of our social media. We post all our episodes to Twitter, LinkedIn, and Facebook. We're also on Instagram and Tumblr. You can check us out each week on Facebook Live, where we talk about what's going on in the tech world and answer some listener questions. Join the conversation anytime via Slack by going to slack.completedevelopernetwork.com.
I just got to say, I'm really glad that I don't have to read that part, because I have such a hard time saying the word water bottle. Sorry. Test code is actual real code. This cannot be emphasized enough. So many developers don't treat tests as real code that needs to be designed with longevity in mind. Just like in other areas of code, patterns have emerged to aid in the design of testing frameworks. To have successful automation in testing, you need to design your test code correctly. Testing design patterns are solutions or ways of setting up code that have been successful over and over again. They were created to solve common problems and are generally considered to be best practices in writing the code that tests other code.
Some of these are very similar to non-test coding design patterns. Others are more specific to testing. There are a plethora of patterns. We chose some of the most common or most important ones to discuss in this episode. Doing the research for it, I found that there's a book by, I'm going to try this name, Soretta Gamba, talking about 86 different design patterns in test automation. I will have a link to that book in the show notes. And we're going to get into just a few in this episode.
So the first one is the facade pattern, and this is a simple interface for more complex code. Likely this code is an API or class library.
you may not need everything that's provided by a particular set of code or an API or library. And because of that, you only want to expose the features that are needed for the facade.
And this improves the ease of use and maintainability of the code. And it also reduces dependencies on external code through a unified interface. Essentially, what you're doing is you're simplifying what's available in the code to cut down on misuse, which is especially important in tests, right? Because you want to make sure that you aren't messing up state somewhere that's going to burn you later. Think about the next tester coming along and messing with this code. You kind of want to put them in the funnel of success so they don't start breaking tests. Here's something that happens a lot when people break tests. Unlike other code, for instance, like if I'm writing a text editor, not that I would ever do that because that's awful. But let's say I was doing that. If I break the code for the text editor, you know what I end up doing next? I fix the code for the text editor. You know what somebody does if they break testing code? What they do next? They comment it out.
I have seen that so many times, and it is so frustrating because it's especially bad with, and it's a junior developer thing because
or a really old senior.
Yeah. The mid to senior level developers that I have worked with don't do this because I guess they've been burned by it. I don't do this because I just looked at it and I'm like, that's why you're no longer testing that. If that test doesn't need to be in there, it needs to be removed. I don't like commented out code. I'll leave it in there for like, all right, let me make sure something works the new way I wrote it, like if I'm refactoring. But as soon as I know it works and it passes the tests, that commented code goes away.
Yeah, and I do the same thing. And I think that's probably pretty common for developers past a certain point in history. It's apparently not very common, for the really old set that didn't have good source control or didn't have it at all. Mm-hmm. I've known developers that like their source control was just other folders on disk. I know some that are still doing that, which we won't talk about that. That's crazy, but people do it. Of course, it's not that terribly different than a branch, right? Like it's like, yeah, it's just another branch, but they don't check it in. But anyway, the thing with all these patterns is you want to make sure that you are setting things up in such a way that human behavioral psychology does not jump up and destroy your tests.
Getting back to the facade pattern, a fluent interface is a way of implementing an API interface in order to provide more readable code. Now, what it does is it uses method cascading to clearly express what that code does.
Yeah, and so your fluent interfaces really make it a lot easier to read the code. They do not necessarily make it easier at the initial phase of writing, right? You're front loading that work, and that's why it ends up being so valuable in a lot of cases, because the person that is taking the effort at first is setting up that value prop for later on for the people that don't care and they just want the freaking test to pass.
I mentioned method cascading. Let's define that. This is a technique where each method that you call returns an object. So what you can do is you can chain together these methods to form a single statement. I remember when I first learned about extension methods, I was super excited. You were there.
Yeah,
I was like, dude, check this out. And I like had this huge long string.
Uh-huh. And yeah, when those first came out, by the way, like the debugging experience wasn't very good. And like with fluent interfaces, it just wasn't, it wasn't all there. But now, I mean, you can make code that anybody can read. The domain specific language thing is huge here. I really, the thing with like a fluent interface is basically you make a class and most of the methods on that class return this. In other words, they return the current class essentially. And then you can just chain the methods together. And so you're mutating state on the class as you go.
Yeah, that's really cool.
So when you're doing these testing classes, especially using a facade, you would only expose what needs to be tested. That's why you're wrapping it with that fluent interface, is you're driving them towards a particular goal and a particular set of changes, avoiding things that they can't do otherwise. So a lot of times you'll see like there's a class and it's got, methods hanging off of it that return the class itself. But some of the methods, return an interface that has a reduced set of functionality. And the idea there is to drive you towards just doing certain things in a certain order. The idea here is that it avoids you getting into a situation where you're messing around with the wrong things because you can't get there in that single line of code. And most people, if they start typing in a fluent interface, they stay there. They don't like go to the next line and, get this massive delegate back from the class and go, okay, now I'm going to mess with that. They're like, no, I'm going to let the IDE do that. I don't want to touch that junk. Right. You're using human behavioral psychology, essentially drive people to not screw up your tests.
Yeah. It really prevents people from really getting into like unfinished or unflagged features. Like if you're using the proper feature flagging, where you may have the code may exist for it in the class, but it's not in that facade or in that interface. So they don't have that access to it through it. And that prevents them, especially if your testers are not your coders.
Right.
Yeah.
Or they're just not very good coders.
Yeah, well, there's that too.
Yeah.
And it could too be that you have some coders that are writing tests and some coders that are writing the code that's being tested, and they're not the same. So if you're not testing your own code, it depends on your team dynamic too.
Yeah, the other thing about this too is it sort of forces you as a tester and a coder to think about the way that the stuff gets used, at a deep level. So it really helps. And another thing that helps a lot is the factory pattern. And that's the next one we're going to talk about. Factories wrap the creation of objects.
Yeah, they handle finding or creating the necessary dependencies of the class that's being instantiated. This tends to reduce dependencies on concrete classes.
Right. And you can use it to create objects based on specific rules. And, for instance, you may have a situation where you've got a lot of classes that implement a particular interface. The calling code doesn't really need to know all the rules for instantiating an object that's the perfect one to deal with a situation. So it passes that responsibility to the factory.
Right, because the factory knows these rules. It has all those sort of if-else or switch statements in there. It knows what's needed to instantiate that object.
Yeah, and the innards of factory classes, by the way, tend to be kind of nasty. It's like a junk drawer for your code. The old premise that cleaning is really the act of putting something where it's less obvious. That's essentially what you're doing here. Is you're getting all that stuff that's really annoying logic that you really don't want to look at again unless it's really relevant, and you put it somewhere so that you don't have to look at it unless it's really relevant.
In automated testing, the factory pattern helps prevent repetition. All the instantiation code is pretty much in one place. That makes changes a lot easier.
Yeah, I mean, you and I have both worked on code bases like this where you go through and somebody has, they got the arrange, act, assert thing, put together, and it's the same in every single test or in like 100 tests, and you have to add a parameter to a constructor. Have you ever done that?
Yes.
Was that the longest 4 hours of your life?
So annoying, man. It is. This is why I really like in .NET you have the MS test. I think InUnit does it too, which is based on JUnit, so I think it's there too. But you can have the test start or test initiate. So whenever you start a test, it'll do that. Now I will put all of my stuff up there. Anything that I need to do, if I'm going to repeat it if I'm going to repeat it at all, actually, no, it's not more than twice. If I repeat it at all in my tests, I pull it out of the arrange and put it up there.
Yeah. And that's great if people know it's there.
Yeah. Well, I have one set of tests where the arrange is just manipulating things in an object that I put up there because 90% of that object doesn't change between each one. And there's like one or two things that I'm like, all right, I'm testing. What happens if I do this? What happens if it's null? What happens if this?
Yeah.
And so I've got different tests for that, but it's the exact same object. Why copy and paste that object all those times? Because literally that's what you would do. You would copy and paste it, which is bad.
Yeah. Anyways. And that works if you got a single test suite, right? But if you've got 10 of them that have to use that stupid object, which
right.
is
So this is where you move into the factory pattern. Yeah. And so like I'm giving a very small example, but yeah, that's right. That's where you move into that factory pattern of, all right, all of the tests in all of the suites are, all the suites use this, or most of them do. Honestly, if more than one does, do it, because if more than one does, then more than one.
More than one is 3 or more.
Yeah.
I can math.
Yeah.
Sorry, you just really messed me up with that one. So yeah, this is really nice when you have stuff like context objects. The worst one in the world was the ASP.NET HTTP context in like web forms. If you wanted to mock that sucker, you're looking at like a day and a half of coding. It was horrendous back in the day. And, like it had all this stuff hanging off of it that you had to mock too. And, sealed classes and stuff. And you're like, well, I got to make a fake of this thing, or I got to, it was really rough. And so having a factory set up to be able to do this without all the pain really makes it a lot more likely that somebody is going to continue the testing process.
Mm-hmm. So what I had referred to that I do is actually the next pattern we're going to talk about, and that's the singleton pattern. A singleton limits a class to only be instantiated once or in one object. Typically, it should be a parameterless constructor. The one instance will be used globally throughout the scope that it's created. So like I was talking about, I would create an object, and then in the arrange for each test, that's when I would manipulate that object for that test.
Right. Because you use it almost like a template object. Yeah. And I did a lot of that, especially like early on, learning how to unit test, because, for one thing, it's easy. Like you can reason about it. All the stuff is right there. And I think at one point too, a lot of the test runners didn't do all the stuff within unit correctly. So like the fixture setup and that kind of stuff, there were some cases where if it failed, it like killed the test runner and you could never tell what happened. And so like early on, I did a lot of that. But the trick with a singleton pattern is you typically want to use it if creating a class requires a ton of resources. And by the way, those resources can be lines of code too, right? Like if it's just a pain. The idea here is this class is only created once, and you're avoiding the cost of recreating the class in that particular scope. The other thing you're probably going to want to do here is you're going to want to initialize this class in a lazy fashion. In other words, instead of going, okay, every time I create this class, I create the class, you'll just do a thing where if you actually need it, you say, hey, give me that class. And if it's not there, then you spin it up. The idea being that it's kind of demand driven, so that if it's not needed, you're not wasting the time and resources to build the object up. Now, for testing purposes, a singleton might be a larger class or a repository. So the idea here being that you only create it one time for all of your tests, and you are able to reuse it over and over again to speed up the testing process. And that's the real key here, is avoiding a situation where you are either creating something heavy repeatedly, or you are creating something heavily in only one place and only using it in one place. All these things kind of have to be balanced out.
The next pattern that we're going to talk about is the null object pattern. Now, I've had some confusion with this pattern, the naming of it, because apparently saying null object means different things in different languages.
Yeah. Well, and it's not null, it's an object.
But a null object, this pattern is very useful because, like Will said, it what it does is it returns an object with empty values for the properties.
So in other words, it's a politician object.
I like that.
That's what we should call it.
I like that a lot. Yeah.
It's a values waiting to be assigned by election. These are really handy like in local scope, right? Like if you're doing something within one memory space and you hit it and you get a value back, and you don't want a null reference exception and you want to be able to act on the thing locally. I really hate this across a serialization boundary.
The nice thing about it is internal objects and parameters exist, but they have those empty or null values, or default values if it's not nullable. And when implementing an interface, the methods return null or do nothing. The idea here is to reduce complexity by not requiring null checks on objects before being able to use them.
Yeah, there's the guy that came up with null, or the guy that like introduced that into common programming languages, has regretted it for the rest of his life. Because it has cost billions of dollars. Like, there are very few concepts in this world that have been as expensive as null.
And the thing is, having null can be very useful if used properly.
Right. And most of us don't. You know, like, we use it improperly until we get hit in the face enough by
That's
it
true.
that we use it properly, and then only for a minute.
With this pattern, methods and properties can be invoked, like we said, without worrying about that null reference exception. And this really improves the predictability of an object's behavior.
Right. Because you don't have something that is going to occur that's going to go outside the stack, for instance, and, you know, throw an exception or, you know, do something weird.
I mean, there's nothing more annoying than not considering a null reference on a nested object.
Yeah, especially deeply nested, or especially my favorite that hit me today was I had a dynamic for reasons that I don't want to talk about. And I was referencing that in a deeply nested object graph that had link expressions in it.
I'm sorry, I can't help but laugh.
And reflection.
Oh, man.
Because you know, like, sometimes you just, like, you got to get where you're going from here.
Yeah. I've been there. I have not done that, but I've been there.
Yeah, it's one of those things where you do / to do : yes, I know. You know, just to tell the next developer, yeah, I got it. Don't tell me about this.
That sounds like one of those places in my early code. Y'all have heard from Cody that I work with that I used to put in / Cody says,
yeah,
fix this.
Yeah. Yeah, this one is one of those that, like, I have to show it to my team as part of a code review next week. And I'm looking at it going, I really don't want to work on this on the weekend, but I really don't want to show this during the week either, because I had to do some evil stuff.
Yep.
To make something work. And it was a bunch of dynamic invocation, and there was a bunch of reflection, and I had property grids in the mix, and I had like type converters. I mean, there's stuff going on. Mm-hmm. And I made it work because I just beat it with a hammer until it did. And I feel really bad about it. But the idea here with the null object pattern is to avoid some of those kind of situations, because one of the things that happened to me was there was stuff that wasn't in the dynamic object, and a null was coming out, and it was changing the way something else was interpreted, because now a where clause in the link wasn't hitting. Mm-hmm. And so stuff was falling out, and then it was expected further down.
I've had very similar things, not the same build up to it, but very similar things happen.
Yeah, it's like, do you remember like doing like treasure hunts in school, like where they give you a piece of paper and it's like, you know, go to this tree and take 3 steps this way and then 2 steps this way, and then it's going to be in the, you know, in the bushes here, and that's the next piece of paper. Like, it's that kind of debugging.
Yeah, I've done that. That is not fun most days unless I'm just in a mood for it.
Yeah. I mean, I was in a mood for it today, thankfully.
Sometimes you're in the mood and you just... The frustrating thing for me is when you set something up that... I guess this was something I did more earlier on in my career, and it didn't come back to bite me until a little bit later in the same code base, but I didn't think about this nested object being null, because like all of my tests, everything had it there until we started migrating data in from an old system.
Yeah. In other words, it was somebody else's fault. That's what I just heard.
Yeah. Somebody else being me 2 years ago.
Yeah. It's still not you. Like all your atoms have changed. It's not you anymore.
Well, the other, like, one of the biggest benefits to testing is the ability to call the nested objects, even if they don't exist. the most annoying thing is that null reference exception, especially when you don't know what's null. When you have like multiply nested objects, like it's really deep and you don't know where in that object you hit the null.
Well, and I've got a bug in my Visual Studio right now that if I hover over something, where it like shows you what's in the object and you can drill down, that crashes my IDE.
I don't think that's Visual Studio. I think that is the stuff you have running on top of it.
It could be ReSharper. So that's a bit suboptimal.
Yes.
Yeah, there's a lot of logging statements in there now, but I mean, you just don't want that stuff, right? Like you don't want to be drilling in with a debugger and trying to find this.
No, you don't, especially, you don't want to ever have to deal with that. And the thing with this pattern is it reduces that frustration by allowing you to call those nested objects without the fear of the exception.
Yeah, and honestly, this helps outside of testing too, because a lot of times when you have a null doesn't mean, hey, blow up and crash my app. It actually means just don't do anything.
You don't have to put in a bunch of null checks either in your testing. And you don't have to test as much for, if you apply this pattern to your code, not just to your test code, then you don't have to worry about testing. Oh, well, what happens if you've got a 3 deep object? What happens if like the parent exists, but the child doesn't, and you're trying to call the grandchild?
Right.
You don't have to worry about testing that because you know that grandchild is going to exist. It's just going to return null. Now, you might want to test what happens when we return null there, but it's a whole different way of thinking, and it actually simplifies your test creation process.
Well, just to keep, beating the drum on how valuable this is, SQL, if you have a null and you try to do an arithmetic operation on it, you get a null. Because null means I don't know. So it's like 1 plus some constant. Well, what is it? Well, it's some constant, some other constant, but I don't know what it is. So it's null.
The next pattern that we're going to talk about is the strategy pattern. And this allows the behavior of your code to be determined at runtime.
Yeah, the idea here is that you define a group of algorithms and encapsulate each one. And this makes the algorithms interchangeable, and potentially you can do it at runtime. A lot of times people will get about halfway there and then they just stop, and that's good too. You really only have to understand the strategy to maintain the test code versus the larger algorithm in a lot of cases.
There are several objects and classes that are involved in this pattern. The first thing you're going to need is an interface that exists that's common to all the algorithms. This interface is called to use the algorithm. So like which method or algorithm is determined by the strategy, the code underneath the interface. You just call the interface.
The concrete strategy implements the algorithm from the interface itself.
Yeah. So if you think about this, that interface is, do the thing, pass in these variables.
Yeah, I think about it stuff like this. Like, for instance, if you had something where you're like, hey, I want to iterate over a group of objects that are in a tree structure. You could have a strategy pattern that says do a depth first search. You could have one that does a breadth first search, and so on. Or that does it based off of the weight of the nodes or whatever. But whatever is dealing with it is only dealing with a stream of objects coming out. It doesn't care how it's getting the other stuff because that's not its business.
Right. And it, based on what's passed in, that's what I was getting at, is, your interface it returns, no matter how it goes through the implementation, it returns the same thing, but it determines the implementation based on what's passed in. So that, through that interface. And then the context wraps the calls to that concrete strategy. This is the information you're passing back and forth, and it's sort of dependent on that interface. And it may even serve as an interface to access data or other areas of your code.
And the strategy pattern allows for decoupled validation. And what we mean by this is this basically makes it easier to extend your tests.
The strategy used may be based on a lot of different factors, depending on how you set that up. And multiple tests can use the same strategy, but in different areas. Multiple test suites can use the same strategies. So it's sort of like when we were talking about the factory pattern. for instantiating objects. This is sort of a pattern for doing things, for running tests, where it's not in the test calls it out, because multiple tests may do the same. You may have multiple tests that do the same thing, multiple test suites with tests in them that do the same, but what it does is based on the parameters passed in. And so that's what the strategy pattern does, is you create this strategy of, all right, well, when these parameters are passed in, or when the input is this, do that. If when it's this, do that. And then you have that all in one place, and you just call that and you pass in the input.
And, speaking of having stuff all in one place, not putting it in places you don't want it, the page object pattern handles a very painful thing for web development. And that is, it abstracts the HTML of a page. And the idea here is that it creates an interface for manipulating elements without looking for them in the HTML. Now, back when I was a young programmer, we did this in a pretty awful way. We would do stuff like have jQuery that we could load up on the page to find an element, put crap in there, hit a button, wait on an async call to come back, and do stuff with it. It was unbelievably brittle, because what happens? The developer lays out the page, they do all the tests, right? And then what the next thing that happens is the guy with the Mac shows up and makes it not look like crap, and now your tests are broken, right? This avoids that problem.
The really cool thing that this does is it creates an object repository of elements. So you have this sort of collection of your HTML elements that are on the page.
Right. And they're usually not, at least in my experience, they're not named based off of what the tag is. They're kind of component named. Mm-hmm. Right. This is the login box, and this is the login box dot login button, so that you can refer to it. And hey, if they change that button to a link, you don't care, because you got some pattern to propagate a click at it, versus I've got to know the button's ID, and don't you ever change this.
Because if they change that, then it's that page object changes it. So it's sort of abstracting that away from you, so you don't have to worry about it.
Right. In other words, you make the test based off of the logic of what is happening from a testing perspective, not based off the logic of what is happening from a page rendering perspective.
Because what it does is it wraps everything, elements, buttons, all of this stuff on a page into a single object that you can then call.
Right. And this includes stuff like navigation, search functions, and all that stuff. So you have like cross-cutting concerns in a lot of these cases too. So you might have the page object that is living, for instance, if you had .NET and you're using a generic, you might have a generic that has all the navigation structure in it. And then, its type parameter is the actual individual page object that has the stuff that's different on the pages, if that makes sense. That might be how you might structure that sort of thing. So you can call it, and the calling convention lets you use objects and not fight with HTML, not fight with all the weird rendering issues either, by the way. For instance, like if you've got Internet Explorer in the mix, thankfully it's dying. But back in the day, that was a real problem. I have a page in one of the apps I maintain right now, and there is a knockout model set on the page, right? And it's got a property on there that says is crappy browser. And if is crappy browser is set, there's a bunch of controls that don't show up. They're not in the DOM.
That makes sense. Yeah, I follow it.
Because of the way that like click events get propagated by Internet Explorer to the containing element, even if it's a drop down list and you moved off of the hover, it's like, oh, you blurred, so therefore hide the element that this thing is in and make it go away, because that makes sense. And so you'll run into this. And so if you have a pattern like the page object pattern, you can get around this, because you can propagate the event some other way in certain screwed up situations. And you'll be surprised how many of those situations will actually occur even today, with browsers theoretically being somewhat compatible.
Now, another thing that the page object includes is an element map, which has, like we said, it has all those elemental properties, but also their locations.
Right. So if you have to trigger a mouse click, okay, if I trigger a mouse click on this element, I know what position I'm on the page and what the Z order is, probably.
Yes.
Right. I mean, that makes a ton of sense. And I lived through the days when we didn't have this. When people were like rigging tests. I mean, I rigged them. And, you're talking like deeply nested jQuery, nightmarish, like stuff you don't want to think about ever. Like, I'm glad those days are gone and that people that do this now get fired. Even though I did it back in the day, it was just really it was not happy times. I'll just put it that way.
Well, the nice thing is I actually pulled a lot of this material from the Selenium forums. Like there's a couple of things about that, but there are some really great UI test suites like Selenium and others that build this for you. Yeah,
I remember when that first came out. Good grief. I'm trying to think what year that even was. Let's put it to you this way. Okay, the periodic table tells you the real truth here, because before Selenium, there was arsenic. So just going to throw that out there. It was bad, but it is really nice because it will generate a lot of this stuff for you and let you kind of have a language for interacting with the page that is abstracted from the underlying mechanics.
Now, talking about the page, for each HTML page, a class or suite of tests is created. And this is going to contain all the tests that are related to that page. In this, the page object kind of serves as a singleton within that scope.
Right, because the page object is massive in many cases. It takes a lot of processing. Sometimes it's, stuff comes out of the database like that. That has a lot of value.
You really only want one instance of that page object per class of tests.
Yeah, and you only want one executing concurrently too.
Right, because that would be a pain.
There's the potential for some very interesting things once you get a web server involved. If you're doing integration tests and you have like WebSockets that are updating the page and two test suites running.
Oh man,
yeah. I've seen people online on like Stack Overflow. Like, I'm not clever enough to even get to the point where I have this problem, so it's great for me. But like, I get an enormous amount of Schadenfreude watching other people do this, and then find out that, hey, this really hurts. Like, don't do that. It's like, yeah, that's right. Put down that gas can while you're using the acetylene torch. Good idea. Yeah. The big thing here though is the separation of the HTML from the test logic. This makes it easier to maintain and reuse the test code as well. Like, you're going to have some repeating elements across pages. So like your web components type stuff, this makes it a lot easier to test those.
It also hides some of the logical programming in these tests, which makes that more readable to non-developers and business people.
Yeah, because like, man, I've been in discussions with business people and use a tag on the page and they think that it means something that it doesn't mean. Like they think the H6 tag is bigger. And it's like, you just don't know HTML at all, man. And they got an opinion. And so if you can keep them from doing that, sometimes the business people can write the tests. Like, they can write acceptance criteria, at least.
Yeah, there are some really, really great test suites. I think Selenium's pretty good about this, where it's written almost human readable.
Yeah, it really is nice. One of these days, I really would like to get longer discussion going about web testing, because there's so much cool stuff in there, because the environment is such a dumpster fire that you have to be good.
What I would like to do, because I've done a lot of research into this, this episode actually came about because I was talking to our lead QA about automated testing, and she was telling me about her frustrations with what's going to take a lot of programming to get set up, and I don't know that. And so I started looking into it, and my research into helping out on that is what led to this episode. But what I would like to do is get someone that really knows automated testing to come in and just talk to us about the whole process, like the setting it up, the running the test. I want to know, and I'll be honest, I want to know, how do I build a test suite? How do I build things, set it up so that someone with no programming experience can come in and write tests? That's what I want to be able to do.
Yeah, and I do too. And I think John Sonmez had somebody on his website at some point about 4 years ago that was doing that. And I can't remember the guy's name and I can't remember anything he was using. So no Google search will turn it up. Hopefully that person or somebody who knows who that is listening, and then we'll go from there.
Yeah.
And so speaking of people observing and listening, you like how I did that? The observer design pattern. The observer pattern emphasizes a one-to-many relationship between objects. So like when the state of one object, in other words, a subject, changes, its dependents or observers are notified of the change.
This allows for loose coupling of objects and classes. Updates and data are easily sent to the dependent objects. We're getting into a little bit of event-driven programming here as well.
Yeah.
With this,
we were already there in the previous point with all the HTML stuff. Anyway,
that's
we just
true.
We didn't acknowledge it because that makes it worse.
Yeah. This you can get into event-driven stuff behind the HTML or in other areas of testing code. The thing with this is adding a new observer doesn't require changes to the parent object or to the subject. It's quite nice. It means that you can add or remove observers as you need them.
Yeah.
The thing to remember here is there isn't a priority in notification. So you can't set it up so that you one observer gets notified before the other.
Right. It's non-deterministic. At least I don't know that I've ever seen any that weren't. That actually were, prioritized. I mean, I think it's probably doable. It's just that is not a thing that you see.
In all the research I did on this episode, everyone said it is not prioritized.
Yeah. Like I said, there's always going to be that one guy with like the full-on Stallman beard and sitting on an island somewhere playing with a soccer ball and a laptop, and he's going to be doing it that way because he's been stuck there since his flight crashed. But for the rest of us, it's just not a thing that happens.
Nice.
Yeah. They call it Wilson coding. So the idea here is this is somewhat like a null object pattern too in some of the utility, because you could have something where there is nothing, that's actually receiving the event and nothing happens. This is a way that some people get around the lack of that in their language, is they'll use events and they'll just go, oh, this is a null event handler. It's a null op. Go on with life. However, you are going to have some interfaces involved here for both the subject and the object classes that are involved.
Yeah, a subject class is required for adding and removing observers. What this is going to have is various notification methods for each observer class, and some classes may share. The interface for this is going to be how the observer objects and classes register themselves as observers of that subject.
Right, and a lot of languages kind of have some stuff around this. Like .NET, for instance, has got the events where you can add and remove.
The information where I got this was from a .NET blog, and it actually showed. I distilled down to the core of what everyone could use,
right,
from the specifics of the C# code that was in there.
Yeah. So an observer is a class that registers with the subject's interface. In other words, says, yo, dog, when this happens, tell me. Right? Like, we need to have a language just called yo, dog.
Now, this could be any class that implements the observer interface. And that interface contains all the methods on the observer that are called when a subject changes state. So you have a class and its state changes. Well, when that happens, it calls certain methods on every single one of these observers that says, hey, I changed.
Right. And hopefully does it on the right thread. But that's something I ran into this week because I was doing stuff in async that was causing events to be raised. Mm-hmm. And it was not on the main thread. And so I was having to marshal the call across. And that was like, and I'm used to doing that from back in the day with WIM forms, but it's a little bit worse when you have like dynamics and generics and you don't really know what type you're actually brokering across that.
Yeah.
And you're having to kind of handle all that stuff and debugging. Oh, by the way, the debugger crashes. Like,
oh, man. That just sounds painful. Like
it was awful. And you know what?
To think about.
I'm the owner of that code because nobody else is going to want in there.
Oh, no, that's true. That's very true. This pattern improves test automation through use of the open-close principle from solid principles. Basically, test code is open for extension, but closed for modification. And the pattern kind of allows for the creation of extendable tests.
Right. So you want to make sure, later on that some other case that you didn't think about is handled, and you don't want to break your existing test. So what do? You potentially add another observer and you just go on.
Yeah, it's really nice because the idea here is you don't have to modify the existing tests. You don't have to change them. You don't have to comment them out. You add another observer to what's going on and add tests based around that observer.
Yeah, and if that observer test fails or one of the other tests fails, you can actually tell which one screwed up.
Right.
Yeah.
Right. Rather than, like we talked about earlier, commenting out tests because something changed and you didn't go in, you'd have to go in and change every little piece there. You can leave those and you can still test what they're testing. Because I can tell you the most annoying thing is something breaking and you going into the code. I've seen this with when I've had to go into other people's code and look at it and go, all right, something's breaking. Let me run some tests on it to see if I can figure out what it is. And I go in and all the tests that test that area of the code.
Yeah, every last one's busted. Yeah, that is not my favorite thing either. And it's really something that's very important to avoid when you're writing tests because, again, the human psychology thing comes in and people are lazy. And unless you have something that's checking to make sure that all the tests are running, all the tests are passing, and the number of tests is always increasing, you will not be able to catch the people that comment out the test to avoid a failing test.
Y'all probably noticed a lot of similarities here between the various patterns that we talked about. That's because these patterns are observations. They're things that people have seen and recognized as, hey, this is something that when done creates better code, creates more maintainable code, creates more extensible code. These patterns are not something that people sat down and thought up, more things that they wrote down as they observed them happening. This has been really a high-level overview of just a few design patterns that are used in automated testing. Since test code is real code, these are similar to the coding design patterns that you will see. The implementation details are going to vary between languages and frameworks. Will and I are both .NET developers, so we kind of talked about that because that's what we're used to. We also talked about some web development because we both do web development. So that's the references that we gave. However, these patterns can be used no matter what language, what framework, or what type of application you are building and testing. The goal here is for you to be able to use this information to understand the concepts behind these patterns when you're learning or implementing them in your own testing. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I've got some advice for junior devs, or really more like mid-level, probably more than junior. Juniors can do this too, but try to find situations where things are messed up and do stuff like writing automated tests or do stuff like writing integrations with those systems. And a good example of this is the HTML page testing. You will learn so much stuff just trying to hack around other people's awful code and industry standards that are awful in many cases. Like, this will make you grow faster than anything else you can do, just about, is to try to integrate with something that is messed up, that has no documentation. It will not just make you better at being able to do that, but it will also make you more understanding of how people approach problems. And so when you're writing your own dumpster fire in some future scenario, you can do it in a way that maybe the answer is a little bit more discoverable, because you now know, hey, this caused me problems when I was trying to troubleshoot how to interact with these kind of elements on the page, or this caused me issues because the threading is all screwed up and I never know which thread is actually, raising some event and I need to handle it. It'll really teach you a lot. So if you can get out there and just find messed up situations and hook into them with your code, again, on your own time, don't do this at work, please. It will teach you just really a lot of really useful stuff. So I can recommend a few things. HTML pages, that's a great way to learn all kinds of very fun stuff. Adobe PDF, just interact with it at all. Once you're done hating your life, you will know a lot of very interesting things. There's just a lot of those kind of little weird edge cases that you can approach and you can really learn a lot and grow from. And so go ahead and go seek those out, because eventually they find you if you don't go looking for them. So you might as well get them now. That's all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.